Hi, everyone. Welcome to this week's edition of Neo4j Connected Intelligence. My name is Kat Eads, and I'm a Partner Alliance Director at Neo4j. In this series, we explore how graph technology integrates with the broader AI ecosystem to solve complex data challenges. Today, we're focusing on a new Neo4j offering, Virtual Graph, that brings the power of graph to Snowflake data with zero data copy or ETL. Joining me today are Farad, Director of AI Product Management at Neo4j, and Pedro, Senior AI Solutions Architect at Neo4j. I'm glad to have you both here. We've got a tight session planned, so we'll go ahead and jump in. Farad, please take us away.
Thank you, Kat, and hi everyone. Thanks for joining us. So to pick up the thread, so today is really about one idea, right? It is getting intelligence out of your connected data without having to move the data around. This is what we mean by connected intelligence as well. The way that we do it is, we do it with the virtual graph. It is zero copy. What we do is we bring Neo4j graph reasoning directly to where your data really resides. You don't need to extract it. You don't need to copy it again. This really leads to the question that you see on the screen, right? Most graph conversations really start with move your data into a graph, and we want to really invert that a little bit. How do you get the expressive power of a graph while keeping a single unmoved sort of truth in the systems that you already run? Everything from here is the answer to exactly that question, really. And we'll show you, and not me, but my colleague here, Pedro, will show you how that works in reality with real data as well. So graph projects really rarely fail on the modeling side of things. They really, fail on the data movement. It is not just for the graph project. It is usually the political challenges and the challenges that you have when you are trying to do ETL from one system to another system. The security, GDPR, and governance reviews alone really adds time into your projects and how they start. There is organizational friction too. If you are coming from large enterprises, who owns that data? Who is going to operationalize it? Who is going to build it? And data teams really resist on standing up and securing yet another data store, right? And then the promising work really stalls before you really start doing it. And there's also challenges around, moving large amounts of data from one system to other system as well. So the real question is, it's not the which graph database, but it is how fast I can reach to production. And then have that value, demonstrate that value without moving the data. And eliminating an ETL in this process is the single biggest, predictor of whether these projects will succeed or not. And what we are doing, right? So we have this new product named Virtual Graph, right? It translates your cipher into the native query language of the source and pushes the work down. In this example, we'll show how that works with Snowflake, and then we do support the other systems as well. It carries a full Neo4j toolset on top, likes of Blooms, GDS, agents, browser, just name it, they work. But you don't need ETL, you don't need ingestion. And why it matters, you might have, a large amount of data that you cannot move, or the traditional ETL projects will have challenges in terms of what I mentioned at the beginning, in terms of, as I call the politics, or, all the friction that you have. A virtual graph deploys against the data immediately, so you can prove the value in really a matter of hours and not really days. And I know that we wrote days there, but it is really a matter of hours. In fact, I was talking to a customer who had been testing this earlier today, and then they told me that they managed to get everything running in less than 10 minutes, and it was really straightforward. And you'll see that through Pedro as well. So three things really comes together. When we look at your to the left, right? So, and we are showing Snowflake as an example here. Snowflake tables and schema, a graph model that can be AI generated or hand built as well. And then the questions that the user ask in Cypher or in GDS, or whether you are coming to an agent as well. And the graph, the virtual graph in the middle is really the translation and the routing layer. It stores nothing in our case, right? It compiles your graph query and it pushes it down to your data source, right? It can be Snowflake or it can be any other, data warehouse or a database that has, JDBC connection at this stage as well, which, we are planning to expand further. What comes back on the right is the real graph capabilities that lives on data. Zero copies with full freshness. You don't need to worry about, am I going to, uh, need to fresh this data? It might have been by, customer data that is updated all the time. Do I need to build complex CDC pipelines to do that, right? You don't need to do that. And graph algorithms like multi-op traversals or page rank are going to work, and that will be grounded with the context for the trustworthy, Gen AI. And the dashed line, when you see, right, is exactly where the ETL used to sit. And then that's the bit that we really removed it. And then how that this comes together, right? So that we get this question a lot. The obvious question is, you know, does this work in, instead of the native Neo4j? And it really doesn't, right? So there are two different tasks that we are, trying to solve here. So the one is we are really looking for the Neo4j is still for real-time, transactional, sub-second latency. You need to do writes, you need the asset guarantees, and you need production applications, you know. And the composite query really allows us to bring that core capabilities with more analytical use cases as well, right? So your data lake brings that information. So you might have increased latency requirement. As I said before, you don't need to move the data, and you might be doing more batch type of investigations. It allows you to really prove value very quickly. So it can, and you have the best of both worlds in a sense that you write one Cypher statement, and then it really allows you to get the data from your data lake and then get the customer, graph through Neo4j as well. One query, multiple sources, unified results, and there is no ETL in between them as well. One use case that I'm hearing a lot is mostly around, if you have a knowledge graph that you built with Neo4j. It might be your unstructured documents that you might bring in together, right? That is a natural graph problem. It is, lots of data, unstructured data you bring in, and then you also want to bring in your data that resides in the lake as well. Or you might have, you might be doing some fraud within, a very deep graph traversals, right? You want to bring three of them together, and then that's how we do the composite query. So the Cypher on the left addresses the databases in turn, right? A virtual graph over Snowflake in this example, a virtual graph over, Databricks that you can bring in as well, okay? And then the composite database really sits over these. It allows you to run the query across all of these. And for a governance-minded team, it's really what that matters, right? You haven't duplicated data, you haven't lost track of the data that you are really dealing with, and nothing really escapes from the controls that you already trust as well. And then there are multiple use cases, and I want to hand over to Pedro, who day-to-day basis work with a lot of customers around this, and then he can take you through that.
Thank you, Firat. Yeah, like Firat was saying, virtual graph is particularly interesting for any domains or industries or verticals or business problems where moving data is difficult. So, for example, highly regulated industries such as pharma and biosciences will immediately benefit from an approach like virtual graph, as you do not need to move data, as well as other examples where moving the data, developing an ETL pipeline might be particularly difficult because of the domain or the volume of data. So another great example is, for example, in ML type use cases such as fraud or churn prediction or other use cases where there is a lot of analytical data, and yet you need to prove or use the value of graph in those domains. And so virtual graph in that case enables a customer to very quickly prove the value of graph and deliver working scenarios. In this case, what we are going to do is to actually give a quick example of a virtual graph. We're going to use a public data set, which is the Yale review data set. We've already preloaded some data into Snowflake, and we will show how in Neo4j you can very quickly create a virtual graph and effectively play with the data and develop your own scenario. The Yale data set is a relatively simple but very expressive data set. It's composed of millions of reviews for businesses, in this case in the US. And they come together with a social network of users and reviews that those users provide. So this is a typical use case for Neo4j. And so what we're going to show is how we can effectively present a graph for that data. And so once we actually implement a virtual graph, that schema will instead look a little bit like what this slide is showing. So we're going to have businesses, reviews, users, together with a set of relationships that will be built by the graph engine and will express that as a graph. So I will start sharing now so that you can effectively see how in practice this happens. Very good. So this is the Aura screen. So I'm effectively playing and showing this in the Aura service. And so what we start with that I am not going to show in this case is loading the data into Snowflake and then creating the connectivity between Neo4j and Snowflake. That is a pretty standard step, so I'm not going to show that here. But what I will instead do is show how we go from 0 in Neo4j to a full virtual graph created. And so we do that by creating a virtual graph instance. And when we do so, we effectively point Neo4j to an instance, a running instance of a Snowflake database. Okay, so in this case, this is obviously hosted in Aura. We select the sizing for the virtual graph. In this case, it's a relatively small subset of data, so we don't require a lot of resources. And then previously, I've already defined the data source that effectively is the connectivity to Snowflake. Okay, so once we do that, we're given the option to create a model. Okay, if we had already created an instance of a model previously, it would show up in this list as an existing model. But in this case, we're going to effectively create it from scratch. And what Aura is going to do is connect to our Snowflake instance, and it will show us the schema for what data is stored in in Snowflake, and we will then effectively turn that into a graph schema. And we have a few options when we do so. We can either define the schema entirely manually. We can generate the schema from the tables and the constraints that are defined in Snowflake in this case, or we can just ask an Aura agent to parse that Snowflake schema and then generate a graph representation from there.
So Petro, I have a question on this, right? And this is interesting. And based on your expert opinion, right? So in what cases would AI be a good candidate for generating the schema versus you are doing this manually yourself?
That's a great question, Farhat. Thank you. Generating with AI works well when you're trying to effectively explore what is there, and you are still effectively experimenting. AI can be very good at extracting relationships and defining the graph from zero. And so it allows you a level of experimentation. And then when you're comfortable that you understand the schema that you are going to build, you typically either generate with AI and then do effectively manual tweaks as you need, or you can also just go and generate from the schema alone if you are confident that you already understand what you're trying to build. In this case, I'm going to generate from the Snowflake schema, from the table schema and constraints, because the graph is relatively small and effectively I already know what I need to build. And so this is the graph representation. I will change a few relationships here so that they match what I am expecting. So I will edit this a little bit manually. And hopefully I'm going to get this right. I'm doing this a little bit from memory. So review for review by. So I'm effectively just tweaking the graph representation. And here tip from. I could also change things like the node names and all of that. But in this case, we're just changing a few relationships. And then finally, I just need to add a final relationship, which is for the social structure of the graph. Okay, so this is for friend. And finally here, I'm just establishing a few mappings. And so now that I've done all of this, I will do a final review just to check that everything is okay. And we're now ready to tell Neo4j to create that virtual graph from the data. This can take a short while, but hopefully we won't have to wait very long. So now Aura is effectively looking at the data in Snowflake, establishing all the data mappings, all the relationships, etc. And hopefully within a minute, we will see this virtual graph instance fully coming up, and then we'll be able to obviously query to use Bloom, for example, to navigate the graph a little bit. We can use things like GDS as well. So we have a full set of functionality that we can use as part of the virtual graph. So now it says it's running, so we're fully set. And so I'll just show a few examples so that you all understand how this expresses itself. So one of the first things that we can do is we can obviously visualize the schema, okay, so that we can see that it matches the schema that we've defined. So this is as we defined early on. So we have businesses, what I call check-ins in that data set, users, and reviews. Okay, and so as an example, let's start by effectively visualizing the social network that is established in the data. Okay, and so keep in mind that in tabular form, this is nothing else but just, connectivity between users. But in the graph, this becomes much, much more expressive. So if we run this query, this should only take a few seconds. So what we're seeing now is Neo4j Virtual Graph effectively expressing this Cypher query into the set of SQL queries that will be necessary to bring the data. And so what we see here is that social graph, so the connectivity between the users that wrote reviews, in all its glory and scale. Okay, so we see all of these links connecting different users, and this is established from that tabular data and then represented as a graph. Okay, we could run other interesting queries. So, for example, let's run a few that I've established before. So this is effectively the relationship between businesses, reviews, and users for any businesses that have been rated with 5 stars and that other users have found useful. So it's a very expressive query in Cypher. We can run that query, and the virtual graph will turn this into the set of SQL queries that are necessary to express that data as a graph. So what we see are businesses such as this one, reviews, and the users that wrote those reviews, all expressed as a graph naturally without needing to do any form of translation manually. We can run a few other ones. So for example, we can look for cases where users, for example, might have written reviews for highly rated businesses and that have given it, for some reason or another, a very low score. So this is the scenario where you're identifying what is called vengeful detractors. So people that, despite very high scores, rate businesses very, very low because, for example, they've had a particular bad experience with a given restaurant or some other business. And so you can see that the data immediately gets turned into a graph that you can explore, and you can see the wealth of representation of the graph very quickly without needing to really deeply understand the data. So the Neo4j graph engine effectively does all of that conversion, all of that, establishes everything that it needs to show you the data in that form. And as a last example, to show other aspects of functionality that we can use, let's also create a small agent within Aura, where we will use AI to then ask questions of the graph without, again, having to move that graph in terms of ETL or moving any data. So we can effectively ask questions about the data entirely within Neo4j. So let's call this little agent restaurant advisor. I'm just putting pre-filled instructions here. I will just copy and paste a prompt that I've done before onto this prompt instruction, which is basically just telling the agent what it needs to do. And so we're all set. This is all that we need. We create an agent. And this agent should now be able to answer questions about that data that is stored in Snowflake, but using the expression of the graph itself. So let's just select that. And Firat, I will ask you if maybe you have any questions that you would like to ask.
Yeah, so this is really interesting, right? So I'm looking for where I would we are planning to travel later in the year, and I like fish as well. So let's ask if are there any good fish restaurants in Santa Barbara? I would really
Very
like
good.
to understand that.
Let's try that. Any good fish restaurants in, you said, Santa Barbara?
Yes, exactly.
Very good. Yeah, so if you remember the schema, so we have businesses, we have users, and we have reviews. And so in this case, what the agent is going to do is to look at the schema of the virtual graph in Neo4j, and it will then build a query that answers this question. And keep in mind that all the data is in Snowflake, okay? So we're not actually pulling anything, we're just using the virtual graph to answer this specific question. So let's try that and see what happens. So the agent is designing the query and queries the data in Snowflake via the graph and provides an answer. So in this case for that, you should go to Brophy Bros or Arch Rock that are both in Santa Barbara.
Oh, I'll keep a note of that. But are there any reviews about them? Because I always read the reviews about them as well.
Sure, let's ask that. What do reviews say about it? And well, let's keep in mind that the agent has the context, so it will know that we're asking about these two restaurants. And so again, it knows about reviews in that schema, and it should effectively translate to the right queries to answer your question. And there we go. So it worked out what those reviews are connected to those two restaurants that you found previously, and it gives you a summary of the positives and the negatives of each restaurant.
And I love the clam chowder, so I know where I'm going.
Well, there we go. I prefer fish and chips myself. All right, I will now stop sharing and we'll continue.
Yeah, let me bring it back the slides. Thanks for that, Pedro. That was really interesting, actually, right? So, and one thing that I need to note as well in this is, the the translation that we do. We show you the AI side of things, but the way that we translate the cipher, the generated cipher into SQL is deterministic, right? If you are writing the cipher yourself, we have a rule-based engine, you'll always get the same results. Obviously, when you are doing the agents and stuff, then you bring the LLMs in and stuff, and then that is different. But if you are writing the cipher yourself, you'll always get the same SQL out of it, right? And then from the enterprise scale, it really important to see how that fits into it. So your data always stays where it is, right? And you can see it like a top to bottom, right? Your data always stays there, and then the graph layer is always in the middle of the hub, if you like, and everything around that ML and Gen AI, it really consumes as one graph. Whether it's unstructured data that you are bringing natively, within Neo4j and then through virtual graph. But I'll let Pedro to walk you through all of these connections and how that works in detail.
Sure, thank you, Farhan. So there's fundamentally 4 big domains in a project that will use virtual graph. One is the knowledge domain. So this effectively unites the data that you have in, for example, a data warehouse, and you can bring data into a composite database from multiple sources where you might have, for example, an existing Neo4j database, and you will then enrich that. You will add virtual graphs from other sources, such as Snowflake or Databricks. And from that, you will build typically a knowledge graph of some kind that unites all of this together as part of the virtual graph. You then can effectively use that to power certain applications, for example, in a machine learning domain, where you will derive features from that graph, including the knowledge graph, to power other types of applications. So that would be a typical scenario in, for example, finance, where you have an existing fraud model and you want to enrich it with certain graph features that are computed on your data without moving it, using graph algorithms that run in Neo4j. So that's where that machine learning domain kind of enters the picture here. Or you might have certain applications that you will build that you want to power based on that virtual graph present as a form of knowledge graph. So you might be hosting an LLM, an agentic framework that already exists, and you want to give it the richness of the graph so that you can be very precise and you reduce hallucinations or whatever metric that you're going for. And again, you do that by using the virtual graph on your existing data without moving it, okay? And because you're doing this from an existing data warehouse, you will perfectly fit whatever compliance requirements you might have because you are not moving it, all right? So from an enterprise perspective, all of this comes together as one centering on that virtual graph, and it does so within existing boundaries of your enterprise architecture, using mechanisms that you already understand. So from an enterprise point of view, this all looks very natural and will fit together very nicely in whatever architecture you already have around your data warehousing.
Thank you, Petro. So, and what you have seen, right? So, is you might have seen and you might have noticed the queries that Petro was running. Some of them were instantaneous. You were just getting the results straight away. And we haven't cached any of that data. It was always going directly into, in this particular instance, to a Snowflake instance that Petro had, right? So there is no caching in the preview, right? So what we do is we always translate Cypher to SQL. If you are coming through the agent, then you are writing natural language, we translate that to Cypher and then to SQL, right? We push that down. You have seen that you get the full Neo4j tooling through the Aura environment in what we shown as well, and it is read-only for mostly for the analytical workloads, right? And that's where we are now. We have been expanding the sources that we have, right? So we tried any JDBC would work behind the scenes, and we'll be adding more and more sources around that. If you like more information, reach out to us. If you have other the systems that you want to use, happy to talk to you. We are planning to go GA later this year. We are expanding the SQL and the Cypher coverage, and expanding the GDS support as well. So what we plan to do next is we are planning to give you ability to cache things. This will be fully under your control. You'll decide whether you want to cache the data or not, right? And then that will give you the sub-second latency, when you need it as well. So we have a number of resources available for you as well, right? And I want to hand over back to Kat to take you through about the next steps.
Thank you so much, Farhat and Pedro. That was fantastic. Really appreciate you both sharing your insights, and particularly the demonstration was especially compelling. It's exciting to hear about how Neo's virtual graph technology can unlock graph insights from Snowflake's already powerful data warehouse without the challenges of ETL or data duplication. To explore the documentation or see more use cases, visit us at neo4j.com. For those of you with specific project requirements or technical hurdles, please reach out to the team at ecosystem@neo4j.com. We'd love to help. So thanks again to everyone for joining this week's Connected Intelligence series. We're here every Thursday exploring how graph powers the next generation of AI. Join us next time for supply chain resilience, mapping multi-tier risk with graphs and AI on Azure. See you next week.